So in this video, I'm going to talk about the two general rules for figuring out whether acceleration is positive or negative. And if you stick around long enough, I'm thinking about halfway through the video, I'm going to do something with the visual part that will really help you understand a different way that you can look at acceleration. So I encourage you to stay all the way through. So the general rules that we have for acceleration being positive or negative, which is what we're focusing on in this video, the direction or the sign of it. So A stands for acceleration, that is an A, and we have a plus or minus for positive or negative. And the rules are written here. If an object is speeding up, acceleration is the same direction as its motion. If an object is slowing down, then acceleration is the opposite direction as its motion. And that gets a bit wordy, and it's hard to grasp at first, so we'll do a few examples just looking at these rules, and then to show how we can make it easier, I'll move on to the second part. So if I change colors here, example 1, let's say this car is moving to the right and the velocity or speed is increasing. So if the speed is increasing, then it's speeding up, and acceleration is the same direction as its motion. It's moving to the right. So acceleration is to the right, and right is generally the positive direction. So we can safely say that acceleration is positive in this case. That seems easy enough, but let's try the other direction. If an object is moving to the left, so let's say the car is moving to the left now, towards the negative direction, and let's say it's actually slowing down. So as it moves to the left, it gets slower and slower. We have to look up here at the rule. If an object is slowing down, then acceleration is the opposite direction as its motion. So it's slowing down because velocity is decreasing, and it's moving to the left. Since it's slowing down, we have to look at the motion and actually go the opposite direction. So I don't know if this is a good color, but the car was moving to the left, but since it's slowing down, acceleration will be to the right, which makes acceleration positive again. And that's a bit confusing to understand at first, because the car is moving to the left, which is negative. The velocity is going down, which seems negative, so why would the acceleration be positive? And if you go by these two rules, you will get the right answer, but if you think about it, that doesn't make sense at first. So I'm going to move on to the second part now. And let's say this whole time there were two Jedis right here. And they have lightsabers, so this is a green one, and over here on the left is the red one. And we're going to say that they were participating in the Jedi Olympics. And what you do in the Jedi Olympics is you use the Force to push the car towards the other Jedi. And the first Jedi to run over the other Jedi with the car wins. So hopefully that made sense. And so now we can look at the same situation we had in the beginning. Car's moving to the right. Velocity is up. Up as in increasing. It's speeding up. And I can ask you now, which Jedi pushed the car? And if you think about it, so the car's moving to the right, first of all. Velocity is increasing. It must have been just this Jedi, because he's the only one who could have gotten the car to speed up and start moving to the right. And what direction? He's standing on the left, so he's going to apply the force to the right. And this force right here, this can tell you what acceleration was. And it's moving to the right, so acceleration would be positive in this case, which we already knew because of the rule, but this Jedi makes it a bit easier to understand visually, especially when we talk about the second case. Now let's say we have the car moving left, and velocity, so the speed is slowing down. And when we did this with the rule, like a minute or two ago, I'm not sure exactly how long it's been, we realized that acceleration is positive, but it didn't really make sense. And so now I can ask you again, which Jedi was the one who did that? If it's moving to the left and it's actually slowing down, it could not have been this one, because no matter what he did, if he had done the force this direction, the car would have been speeding up to the left. But since the car is slowing down, it must have been this Jedi who counteracted the motion of the car by applying the Force to the positive direction. And since this Jedi is pushing really hard this way, the car starts to slow down, even though it was moving to the left originally. And so we've concluded that it was this Jedi, and it was the positive direction of the Force, so acceleration is positive again. So we'll do one more example, and we'll do it both ways with the rules in the Jedi. So let's say the car is moving to the right this time, and it is slowing down. So we can look at the rule, and it clearly says if it's slowing down, acceleration is the opposite direction. So it's slowing down, we look at direction, direction is to the right, so the acceleration must be negative. So we're gonna circle negative. We know that already. Now let's double check that with the rules that we know. With the Jedi. So since the car is moving to the right and slowing down, it's pretty obvious that it couldn't have been, or it will be obvious as you do this more and more often, that it could not have been this Jedi. Because if he had done the Force, the car would speed up towards the right. So it must have been this Jedi who applied the Force to the left. And he's pushing to the left, so the car was moving to the right, but it slowed down. So it's going to be negative acceleration. So you can do it both ways, where you look at the rule and then you use the Jedi or whatever works best for you to confirm what you already thought you knew. And a lot of people think this Jedi thing is easy. A lot of people don't understand it at all and like to stick with the rules. But in physics especially, there's lots of different ways to understand different things. If I was unclear in this video, feel free to message me or comment and I will try to fix that. And thank you for watching.